Hello everyone! In this video we are going to take a look at how to work with lights, how to create shadows with them, what are the quirks of light occluders, and also how to apply normal and specular maps to objects in order to make them look like they're in 3D. So let's get started! Now I have this scene, and the first thing that I'd like to do would be to make it a bit darker so that we can actually see the lights that I'm going to add. To do that, I'm going to simply right click and add a child node and add a canvas modulate node. This canvas modulate node simply has a color property which, if white, does nothing to the current scene, and if it's any other color, and if especially it's a darker color, it will make the current scene darker. Now that our scene is darker, let's actually add the light to it. So I'm going to right click and add child node, and I'm going to search for light. And in here, you'll see that I have a directional light 2D and a point light 2D. Now, the directional light 2D is the simpler one to use because it behaves pretty much like the canvas modulate. As you can see, it applies a light to everything. So if I change the color of this light, you'll see that the color of the whole scene changes. If I change the energy, the whole scene is lighter or dimmer, and if I change the blending mode, it changes the blending of this light with the pixels of the scene. Okay, but I'm going to reset the settings and maybe, actually 4.3 was pretty good. Let's have a dimmer scene because we want to light it up with point lights. Now, just as before, if I want to add a point light, I have to right click and add a child node, and I'm going to select this time a point light 2D. Now, if I click create, you'll see that, well, nothing happens. And nothing happens because we haven't assigned a texture to our point light. The kind of image that we can use for this texture is a black and white image, similar to, this one, with white symbolizing light and black symbolizing, of course, the absence of light. So if I now get back to my point light 2D, I can simply drag and drop this texture here, and you'll see that now I have a little, actually a pretty big light here. Okay, let's make it a bit smaller. We can go to the transform and maybe make the scale something like this, and we have a pretty nice light that we could put on, I don't know, maybe this window or something. Now, there are other ways of creating this texture. Instead of this, we could simply be using some gradient. So I could click here and select gradient texture 2D. And first of all, you see it doesn't look really good because we do not have a radial gradient. To do that, I'm going to go to fill and select here radial. Also, now we have to set this point to be in the center of our texture. So I'm going to set here 0.5 and here 0.5. And as you can see, the light is at the borders and the darkness is in the center. So let's reverse that. I'm going to click on the gradient and simply take these colors and put them in each other's place. Now, one other small issue that we have is that our light gets cut off by this texture. So we can simply drag this black texture until we have a perfect circle. And as you can see now, we have a pretty nice light here made out of a gradient and not out of a texture. Okay, but what if, for example, we wanted this light to only affect certain elements in our scene? As you see, I have a tile map which is made out of 5 tile map layers, and let's say that we wanted this light to affect only the background layers, to maybe change how it looks outside our lighthouse here. What I could do would be, first of all, to make this light a bit larger, maybe something like this, and put it here. And I could select what layers it's going to hit. So if I look under range, you see that I have here an item call mask. So, for example, what I could do would be to say that this only meets with items on layer 2. Now, I don't have anything on layer 2 at the moment. So how do we add something to a layer? Well, let's go to this first tile map layer, and you see here that under visibility, I have a light mask. If I set this light mask to 2, you see that the light has been applied only on this background. If I want to also apply it maybe on this bush here, I can make this bush to also have layer 2. And if I want to apply it on the ship, I can make this have layer 2 as well. And you saw a small difference on the ship as well. Now, one thing to keep in mind is that this only works with point light 2Ds. If I were to go now on the directional light and only make it, let's say, light the background, which was on the layer number 2, you see that there is actually no difference. Okay, but let us get back to the point light 2D because I want to show you that you can also select which nodes are going to get lit up based on their Z index. So for example, you see here that I have a range which is from -1024 to 1024. I can set this range to be, for example, from 0 to 1024. Now, if I were to go to my tilemap layer 1, despite it being on layer mask number 2, so the correct layer mask, if I were to set this Z index to -1, you see that my background is no longer being lit, while tilemap layer 2, which is this bush over here, is being affected by light. Okay, now I have added to this scene a few more lights, which are these lights coming out of windows. And yeah, the scene looks a bit better, but we still don't see the full power of the lighting system. And we don't see it because our lights currently cast no shadows. So how can we make our lights cast shadows? To do that, we would need to make use of a node called a light occluder 2D. And how can we create such a node? Well, there are a few ways to do it. For example, I could drag this icon SVG in order to create a sprite 2D and maybe make it smaller, put it somewhere around here. And what I can do is to click on this sprite 2D button and click create light occluder 2D sibling. Now here I could modify these settings to change the shape of the occluder to be whatever I want, but I think it's pretty good, so I'm simply going to click on create. Okay, but this is still not what I expected. This object does not cast any shadow, and this happens because our lights do not even have shadows enabled. So let's simply go to the first light that is closer to my occluded icon, and let's simply go to shadow and check this enabled checkbox. Now, as you can see, our sprite here is actually casting some shadows, which is really amazing. Now, what we can do is to create a node 2D, and let's group our icon and light occluder together. Because they are now grouped, we can pretty much move around this whole thing, and you see that it's looking pretty good. It's casting shadows no matter where I am in relationship to the light. Okay, now let us make this shadow behave differently for the light that is being cast from this window. So what I'm going to do is first of all move my node here with the occluder, and I'm going to go to the light and enable its shadows. Now, as you can see, the shadow looks pretty much the same, but what I can do is to make it be smoother. And to do that, I simply have to modify the filter. Now, for example, I could select PCF5, and this will allow me to move this slider, and maybe I can get closer, and you'll see that our shadow becomes smoother as I increase this filter smooth, and it's smoother because the shadow is now not made out of a single band, but is made out of 5 bands, so from far away it gives the illusion that it is very smooth. Now, of course, if I increase this too much, the 5 bands are going to be very noticeable. But what you can do maybe to reduce this problem is to change to PCF13, which is going to use 13 bands instead of 5 and makes it a bit less noticeable. Okay, but what if I didn't have a sprite? Well, I could be making an occluder out of a simple polygon. So let's first hide this node 2D and let's take a look at these 2 big lights that we have here. Now, take your sunglasses because these 2 lights are pretty strong. Okay, but let's make them be occluded at this triangle where obviously there is no light. What we can do is to, okay, maybe I'm not zooming it so much to not blind you, but what we can do is to simply add a new node. I'm going to right click, add a child node and select light occluder 2D. Now that I selected this, you see that I have a warning message because I basically have no occluder, but I can create points. So if I click this, I can then click here, and yeah, it asks me to create and I create. So I click again here, then here, 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 and here, and I have a reasonable enough polygon. And what I can do with this is to, well, do the same thing as I did with the sprite before. I'm going to the big light and I'm activating the shadows, and I'm going to the other big light and activating or enabling the shadows as well. And as you can see now, the shadows look much better, and this triangle here is going to not allow the light to pass and overlap with the other light, except in this region in which the triangle cannot reach. Okay, but what if we wanted to apply an occluder to everything? We could of course create occluders just like we did for this triangle, but it's going to be pretty complex to do so for everything. And what if I want to change how my tilemap looks like? Then I have to change the occluders again and again, and it's not very easy to do that. So what we could do would be to add the occluders at the tilemap level. For example, I could go to the tilemap, select the tile set, and under rendering and occlusion layers, I can add a new element. This is simply going to add an occlusion layer that's on the light mask number 1. Now, just as you would do with the physics layer or navigation layer or whatever, you could click on the tile set, go to the paint mode, and select a property and the occlusion layer 0 property. With this, what we can do is to simply apply to our shapes whatever occlusion polygon we want. We have these simple rectangular shapes here, and as you can see, I have applied it to the boxes. And if I now take a light, let's take window light number 1, you'll see that the boxes already cast a shadow. Now, this is pretty nice, but I can apply it on more complex shapes. For example, I could be applying the occlusion layer to a shape looking like this T shape here. And I just have to make new nodes here. And yeah, after I click on this, you see that these items cast shadows as well. And this platform is going to cast shadows as well. And if I come to this one and remove these 2 nodes and apply it, the whole platform is going to cast shadows, and the whole scene is getting a better representation of what would happen in real life. Okay, now what if we were to work, for example, with this more complex shape, which is a ladder? Well, we might encounter a small issue. The issue is that we cannot draw 2 of these polygons. So for example, I could start by trying to make this first polygon here for the left arm of the ladder, and yeah, I would say, yeah, this is fine. Then if I wanted to draw the other polygon, I wouldn't be able to, because as soon as I finish the polygon, yeah, the previous polygon gets removed, and yeah, I cannot apply it on both arms at the same time. A solution that I found for this was to simply create a new occlusion layer, because with a new occlusion layer, I can simply swap here to occlusion layer number 1, select this ladder again, and simply make the polygon fit the shape of the arm that I didn't cover with my first occlusion layer. And now if I apply it, you see that both arms of the ladder are going to cast shadows. Now, we kept talking about occluders, but we haven't talked about their properties. So first, let's make a new occluder polygon 2D, and let's maybe give it a shape like this. And as you can see, it behaves like a normal occluder. However, what we can do is to make this occluder not be closed by unchecking this closed property. And as you can see, the last edge that we drew is no longer here, so it no longer casts a shadow. So if I move with my point light, you'll see that if I'm on the left of this occluder, I cast shadows to the right, and if I'm on the right, I cast shadows to the left. Now, why am I saying this? Because the occluder also has a property called cull mode. This basically specifies which face of our shape is going to cast shadows, and generally only the outside shapes are going to cast shadows. But now, how can we tell which shape is outside? Well, first of all, you see that this cull mode is disabled, so we actually don't care, we just cast shadows no matter what. But if I were to set this to clockwise, you would see that I no longer cast any shadows, but I can move with my light and cast shadows from this side. Now, how does this work? Now, if you remember, I started drawing my occluder from point 0, 1, 2, and 3. So this was 0 and this was 3. Okay. What happens is that depending on the order in which I started drawing this, I'm going to go clockwise to see which edges are inside and which edges are outside. So if I were to go clockwise with this edge would be inside. This edge is going to be inside and this edge is going to be inside. Now, after reaching the third point, I'm going to go around the edge, and if I'm turning back, this edge is going to be outside, this edge is going to be outside, and this edge is also going to be outside. Now, what does this mean for us? It means that when we cast a ray of light, if the last element hit by this ray was not an outside edge, it's not going to cast a shadow. So, for example, if I cast a ray in this direction, you'll see that the first edge that it hits is an outside edge. And if I move further, it's an inside edge. So this is not going to cast any shadow. If I do the same here, you see, I hit an outside edge, and here I hit an inside edge. If I do the same here, again, same thing, I hit an outside edge and an inside edge. So that's why, in this moment, I cast no shadows. Okay, now let's assume a different position. For example, if I had the light here, you see, this would cast a ray towards this edge, which, as we said, is an inside edge. And the final edge that it touches is an outside edge, so this is going to cast a shadow. And we can test this in practice. If I move this, you see this edge is going to cast a shadow. Okay, now the other cool mode is called the counterclockwise cool mode, and what this is going to do is to basically do the same thing, just reverse which edge is outside and which edge is inside. So if I take my light here, maybe we could test another example. So first of all, our polygon started here and ended here. Okay, this time we said that we are going to go counterclockwise. So if you remember, before we went like this, now we go counterclockwise. So what we are going to do is basically go around this and take this edge. So this is going to be considered an inside edge. If we continue moving, we reach this edge, which is going to still be inside, this edge, which is going to be inside. And at this point, we turn basically around. So the other edges are going to be outside edges, outside edge, and outside edge. Okay, so now if we were to cast this light on our edges, what happens? Well, first of all, this light is going to hit an outside edge and then an inside edge, which means that here we have no shadow. But in this other case, we are first hitting an inside edge, and here we are hitting an outside edge, which means that there is a shadow. And in this case, we have something similar. We hit an inside edge and then we hit an outside edge, which means that we have a shadow here. Okay, now this cool mode is interesting to say the least, but we don't really know what it's good for. So let's actually see. For example, let's say that I have this light that is lighting up these sprites and is using this occluder to cast shadows on the sprites. A problem that I have is that this sprite is never going to get lit because it's always going to be behind the occluder. But in real life, you might expect that the first thing you hit the light with would be lit. So how can we achieve that? Well, if you remember, the occluder is basically dictating which part is inside the shape and which part is outside the shape. So what we have to do is to go to this light occluder and no longer cast with both edges, only cast with the edges that are outside. And for that, all I have to do is to set the cool mode to clockwise. And as you can see, now I can take this light and move it around my sprite, and the sprite is going to always be fully lit, but it's going to still cast shadows on the other sprites. Now, since we are in this scene, let's also talk about the case in which we do not want to cast shadows on any of our sprites, but we still want to cast this beautiful shadow in our scene. Well, to do that, we could specify through the shadow the items that are going to be, well, shadowed. So if the items are on layer 1, then the shadow is going to be applied on these items. If they are on another layer, then the shadow is no longer going to be applied. So if I were to go to sprite number 1 and change the light mask from 1 to 2, nothing happens. And nothing happens because this is actually an issue in Godot 4.3. However, if I now move to Godot 4.4, you'll see that this item call mask is set to 1, And if I move any of these sprites from layer 1 to layer 2, they are no longer going to be affected by this shadow. And by the way, what I forgot to mention was that the item call mask for the actual light is set to both 1 and 2, because if I didn't have this on layer 2, then it wouldn't light up any elements that are on layer 2, so basically wouldn't light up these two elements that are sitting here. But yeah, that's pretty much it, and I'm happy that this got fixed in Godot 4.4. Now, for the last part of this video, I am actually very excited to show you how we can turn this bland little star into a star that almost looks like it's in 3D and that is affected by light in the way you'd expect something with this shape to be affected by light. Now, in order to achieve this, what we have to do is to add a new sprite 2D to our scene, and instead of simply dragging and dropping our star in here at texture, we are going to use a new canvas texture. We are using this because it allows us to have a diffuse, normal, and specular map. Now, for the diffuse texture, you would use the texture that you'd expect, the normal texture. I was going to say normal texture, but this one is the normal texture. Okay. Now, for the diffuse texture, we are simply going to use the normal texture of the star. So I'm going to drag it here, and yeah, maybe let's make this smaller, 0.25. Okay, and now we have a star that's roughly the same size as this. But as you can see, it still doesn't look as good as this one. Well, of course, it doesn't look like that because we don't have a normal and a specular map. But what are these normal and specular maps? Well, a normal map is basically an image that's looking like this, which pretty much tells Godot in which direction is each face of our star being pointed. So, for example, in this image, purple basically means that this face is pointed more towards the right, and this cyan or turquoise or whatever is pointed towards the top, and any other combination of this greenish blue color with purple is going to be pointed in the other direction. So as you can see, this darker blue is going to be pointed towards the left. Okay, and if I were to simply go to my sprite again and drag this normal map here, you see that I already have made my star go 3D. And if I move my point light, you see that it also shines almost the same way as this other one. One other thing that I can do is to make it even better by adding to my little star here a specular map. Now, the specular map tells Godot where the reflective spots of this star are going to be and how strong they are going to be. So, for example, if I were to use this one as a specular map, then wherever you see more white, there is going to be more light. So we'd expect here to have something very bright and here to have something that's not very, very bright. So if I now apply this specular map to my star, let's drag and drop it. Sorry, let's drag and drop it here. You'll see at first that nothing pretty much happens. It's pretty much in the same way. However, this is because if you read the documentation for the shininess, the default value of 1 basically disables the reflections entirely, because this value is basically saying how small or large the bubbles of reflections are going to be. So if I make this smaller, you'll see how it immediately reflects a bit more light than it did when it was very large. And if I make it the smallest, then it's going to fully reflect whatever light has been set in this specular map. And now if I move this around, as I said, this is being lit up, but if I go here, I can barely make out any shape of this corner of the star because of how strong is the specular map on this side compared to this side. And of course, you're not even limited to using only this simple texture as a specular map. What you can do is to use, well, anything. For example, I have this texture which I scratched in Photoshop, and if I click on my Sprite 2D again, what I can do is drag and drop this texture here, and you see this texture has basically been applied on this star, making it look more scratched and maybe more old. Okay, but I'm not going to simply show you how to use normal maps and specular maps without actually showing you how to create those. So what I'm using is a free and open source program called Laigter. In this program, I can basically import whatever image I want, and I can simply play with parameters in order to get to a shape that I would expect in real life. So, for example, right now I am in the texture mode view, but if I were to go to the normal map of this, you see it looks like a star, but it's not really the shape that I would like. I would like it to be taller at the middle and maybe to not be as tall in these crevices. So what can I do? Well, I can modify these settings of my star to maybe have a different height. And if I set the height to 0, you see the whole star is starting to look kind of flat. And if I increase the height, the whole star is starting to feel like it's taller. Now I could also modify this distance to see how much of this star plateaus here at the top. And if I increase the distance to the maximum, you see the star is now only here, the tallest, and it gets lower and lower the more I move towards the side. And I could increase the softness to see how soft or rough I want the shape of my star to be. Now, this is not only limited to how the normal map looks, I could also swap here on the specular map and again modify whatever values here on specular to change this texture to whatever I want. I could make the star be less bright or less reflective, let's say, and I could change the contrast and yeah, a lot of other settings. Okay, now what I also like to do is to not always stay in this specular and normal map mode, because sometimes it can be pretty hard to read what the final result might look like. So what I'm doing is to go into the preview mode, which gives me a little flame here that I can control to light up my image and to see how the final result might look like. And not only can I light it up, I can also modify the color of my little flame here, and I can also modify the height or intensity of the flame. Now, I haven't talked about the height of a light, and you might be wondering what is that? Well, since we are simulating that our star is in 3D, then we could also simulate that our light is in 3D. So if our light had the height of 0, we could assume that the light is basically at the same level as the star, so you can see that it barely reaches any spot because it's being blocked by these sides of the star. However, if we make the light higher, you'll see that it starts to reach these spots and only lights these middle high points. But yeah, there are a bunch of settings that you can play with both on the light and on the current star object to modify how it will finally look like. And if you are satisfied with the result, you can simply click on export here and select what you want to export, maybe the normal map, the specular map, or whatever maps you decide to make in here. Okay, now as a final thing, I have also talked about the height of the light in the Laigter program. Well, in Godot, we also have a height for our light. So for example, if I'm right here near the star, the height is 12. If I set it lower, you see that I basically light up less because the light is lower and these parts of the star are basically casting shadows on these left parts of the star. However, if I increase the height, you see the light is up in the ceiling and is basically almost fully lighting everything on this star. And yeah, on this other star as well. Let's also give her some light. But yeah, I really hope you found this useful, and if you did, please consider liking and subscribing to the channel. Thanks a lot for watching, thanks to my Ko-fi supporter, and see you in the next one.